Thanks for watching. If you find my videos helpful, please like, share, and subscribe. And please look in the description beneath this video for useful links to other videos and resources to help you learn chemistry. For today's video, I'm going to teach you how to answer the question shown here. I invite you to pause the video right now and try this question on your own first, then hit play and I'll show you how to do it. One way to wrap our heads around this is to memorize the information shown in this chart, which shows all of the physical interconversions of different phases, solid to liquid, liquid to gas, and solid to gas, as well as their reversals. And it also shows us which ones are endothermic, or delta H is greater than 0, or exothermic, delta H is less than 0. It also shows their relative entropy changes. An alternative way of being able to navigate through this is to just imagine your own experience interacting with water, which I'll explain in just a moment. Before we get to that, what I'd like to do is name each of these things. For example, if you have liquid water and it turns to solid, what is the name of that phase change? Yeah, liquid going to solid is freezing, or the technical name for it on the chart that I just showed you is crystallization, but let's keep it simple by calling it freezing. Now, what about solid CO2 to gas? This is weird, but you've experienced it if you've ever seen dry ice, which is solid CO2. It converts directly from solid into gas. That is called sublimation. Going from gas to liquid, as we see here, that is the reverse of evaporation or vaporization and is called condensation. And going from aqueous to solid is not as straightforward. However, as far as this kind of question goes, you can still arrive at the same answer if you replace AQ with liquid. Now, I realize that they are not the exact same thing. AQ is something dissolved in water. Liquid is something else. For the sake of navigating this kind of question to the correct answer, if you just replace all AQs with L's and treat them like that, you'll end up getting the same outcome. So as I convert from liquid to solid here, again, that's crystallization, or common layperson's way of saying it, freezing. Now we have to think of what is endothermic. Endothermic is something that consumes heat. So if you're near it when it happens, it actually feels cold. Now I just think of my own personal experience with water. If you put water, liquid, on your skin and then go outside, does it feel hot or cold? Yeah, it feels cold because that liquid water is evaporating. It's turning from liquid into a gas, sucking heat out of you. So the process of converting from liquid to gas, from your own experience, is endothermic. It consumes heat. That's also why you have to add heat to a pot of water in order to get it to boil, convert to a liquid. Now, if liquid to gas is endothermic, that means that its opposite, gas to liquid, is exothermic, as we see in option C. Now, what about liquid to solid? Well, let's think of the reverse. If you have solid water, that is ice, and you put it in your hand and watch it melt, turn into a liquid, does it feel warm or does it feel the opposite, cold? Yeah, it obviously feels cold. The reason is because the solid water molecules are sucking heat energy out of your hand, using that heat energy to wiggle apart and convert from a solid to a liquid, that is to melt. So melting, because it consumes heat, is endothermic. Therefore, its opposite, freezing, actually is exothermic. By analogy then, this one, liquid to solid, would also be exothermic. Now, what about solid dry ice going to gas? Solid to gas, is that endo or exothermic? Now, we don't experience that with water, but as you can well imagine, having seen dry ice, in order to convert those locked, ordered solid molecules into gas, it does require an investment of external heat. Because it feels cold, requires external heat added to it to make that phase change happen. It is endothermic, which therefore makes option B this question's correct answer.